You are listening to the BSI Business Growth Toolkit, a series from The Standard Show, the podcast that brings you the stories behind the standards, in collaboration with Innovate UK Business Growth.
Hello, my name is Matthew Childs, and this is the BSI Business Growth Toolkit, a series from The Standard Show, developed in collaboration with Innovate UK Business Growth. Innovate UK is the UK's innovation agency, and Innovate UK Business Growth is a key part of the agency's deep investment to help innovating businesses grow and scale, supporting them with advice on becoming investment ready, internationalising, and managing how they innovate. In this series, we're looking at the relationship between standards and some key business issues, with particular relevance for SMEs. This episode of the series is on scaling up, and our guide is Peter Stirling from Delta G, an innovative deep tech startup. Before we hear my conversation with Peter, a reminder that you can rate, review and subscribe to The Standard Show wherever you get your podcasts. And you can get in touch and find and follow us on social media too. All the details are in the show notes. And the show notes are also where you can find a link to all the episodes in the series. So, Peter Stirling is Chief Executive and co-founder of Delta G. Spinning out from the University of Birmingham here in the UK in 2023, Delta G is a quantum technology and gravity gradiometry company. Its technology is a world first. Portable sensors to accurately detect buried features under the Earth's surface. Peter leads a team of experts from science, engineering and business, supported by end users for this technology from a variety of sectors, including energy, transport and defence, with an amazing collective mission to create the Google Maps of the underground. Delta G was recently awarded a Small Business Research Initiative contract by Innovate UK to develop the next iteration of its technology. I started by asking Peter about this technology, the fantastically named Quantum Gravity Gradient Sensor. Tell me about this amazing technology. Now, Quantum Gravity Gradient Sensor. Now, don't lose me. I'm really keen to know what exactly is it and how will the world change because of this tech?
Well, the world will definitely change because there's currently a gap in sensing capability. There are existing sensors that can generate data about the subterranean environment, and they are very useful and still very important moving forward. But this sensor can generate new information that fills a significant gap in the landscape at the moment. And in terms of the technology, I have a good appreciation of it, but not as much of an appreciation as the academics that have developed it. But essentially, what the group at Birmingham are experts in is generating cold atom clouds. So what they've done is developed a research device that has basically a large kind of 6-foot cylinder. And at the top and the bottom of the cylinder, there are specially designed vacuum chambers in which they generate these clouds of atoms using specially designed lasers. So what they do is, but simply, and there's a lot more to it than this, but effectively they generate these clouds of atoms and then they use lasers to make them stationary. So the atoms are moving as fast as a fighter jet, but we suspend them and make them stationary. And then we take this device out into the field, if you like, for to perform its measurement. And then we drop the clouds of atoms. And remember, we've got two groups of atoms, one at the top and one at the bottom of the tube. And then we use a laser ruler between the two vacuum chambers to measure how these atoms, which remain in the vacuum chambers, they don't go into the ground. We're not sending any signals into the ground. And from that, we understand how they're pulled by gravity. And from the way that they're pulled by gravity, we can determine specific artifacts in the subterranean environment, such as materials or deposits or infrastructure.
And how does this change the way we would normally, assess the subterranean? How big a change is this?
It is significant because there is existing incumbent technologies like ground penetrating radar that's sending radar signals into the ground and looking for changes in that signal to determine where there might be certain materials or assets. And then there are existing gravimeters that are based on mechanical systems which do provide useful data, but in some instances they take quite a long time to settle. And also they can drift and wear over time, again, because they're mechanical systems. So this device isn't affected by any of those issues, and also is very rapid settling. It takes zero settling time. We can just take more rapid measurements and gather more data more swiftly.
And give us a sense, Pete, where would we have sort of a real-world application here? What sort of sectors and industries might be using this technology?
So the research group, even before the spin-out, had long-standing relationships with construction and infrastructure companies, civil engineering companies, large geo consultancies that are already using existing technologies to do ground surveys and provide data to their clients. So we'll be looking to work in partnership with those to develop use case tests and demonstrate the technology that we're currently developing at the moment. And also at the back end of last year, Delta G was awarded a Innovate UK funded SBRI contract, and in order to apply for that contract, we had to have a government sponsor. So we got the Department for Transport involved, who are keen on the technology, and we're likely to be developing use case deployments with national highways and Network Rail and potentially other groups under Department for Transport.
So you have this new tech that will change the way things are done. Fantastic applications. Where's Delta G on its scale up journey?
So we're only 8-9 months having spun out of the university, but we did quite a lot of preparation before that. So the company was a little bit mature than your average university spin out. But we initially had an Innovate UK grant under a quantum feasibility award. And then we raised 1.5 million of equity from VC and angel investors. And that's put enough money in the business to build the first commercial demonstrator. So the research device, whilst it's very sensitive and the results it can obtain are of interest to industry already, we are focused on reducing the size, weight, power and cost of that machine. So the bill of materials for that device is very, very high. Its weight is very, very high, and it can't go beyond the road outside of the university laboratory. So the funding that we've raised, we have a rapid development program to build the first commercial demonstrator that's basically taking the device from the size of a large fridge freezer and a large 6 foot plus cylindrical tube with the clever atoms and vacuum chambers in it, to something that's more like the size of a small oven on wheels that can go out into the field. And it will be going into more controlled environments such as tarmac spaces rather than hilly areas, but it will be able to get out into the field and take readings. So we expect to have that device out deployed in late autumn of 2024. And the good news is the contract that we won at the back end of last year that I mentioned earlier with the Department for Transport is that's funding the development of the next iteration of our sensor. And that will further increase the sensitivity, but it will also make the device onto a semi-autonomous mobile platform that will allow us to send the device out into the field, but a more rugged field, if you like, and because it'll have a self-leveling system. So this will be an autonomous, a bit like a moon buggy, basically, with a further improved sensor and a self-leveling system. So the vehicle will move forward, will stop, will take a reading, and it will go on to the next sensing spot, will take a reading, and will go and autonomously map a site. So that's where we're headed, and that device will be ready in second half of 2025.
So it's relatively early days in the growth of the business. So the business is growing. I just wonder, how have standards helped so far, and where are they helping now in this particular part of your journey?
So I've got experience working with ISO 9001 previously in quality for engineering developments. So we will look to bring in 9001. We're already considering in our designs how we will, operate towards those standards. And more recently, we've come across the innovation standards, and that's really been of interest to us because we're moving rapidly through various technology iterations. So the more we can evidence that we are adhering to appropriate development and standard protocols, the better, because we have to build confidence with all of our key stakeholders, be it the end user customers, our investors, future employees, government funders, that this technology is being built in an appropriate manner that will stand up to the tests that it will face in the field. So that's how we're following these. That's how it's definitely going to help the development.
But you've talked there, Pete, about 9001 for the sort of quality management, and the 56,000 series, they're looking at sort of innovation management. I just wonder, as an organisation, at this particular point in your journey, what are the standards or areas of the business in which you may look for standards to support your growth?
But certainly in the engineering design, in respect to 9001, to make sure that this device is following standard development processes, and we're documenting that, and we're ensuring the quality for our internal processes, but also we will be ramping up into manufacture of these devices. So there's a scalability and a design for manufacture program that we can seamlessly get into scaled up manufacturing, most likely with an external contract manufacturer. And in terms of the innovation management, that's something that's we've come across more recently, and we're currently learning about. But it's definitely an area that can help us chart our innovation journey and ensure that we can evidence the progress that we're making and be guided in the progress that we're making, so that we rapidly develop the technology, because it's really our focus is on how do we develop the core sensing capability. The initial market that we're going at is construction and infrastructure, and you can include utilities within that. But we have also additional opportunities for the sensor in resource identification, be it water and oil and gas, or mining and materials. But an additional capability of the sensor is its ability to provide position and navigation capability without the need for accessing satellites. So when you take a gravity reading and you match that reading against an existing gravity map in near real time, you can give yourself a location. So we've had long-standing interest from defence and security sector in this technology. So if we're going to be supplying sensor capability and data acquisition capability into these domains, we have to have rigorously developed and applied the appropriate standards to the development to ensure that we can step into the market when we're ready.
You've mentioned already some of the sort of stakeholder interest and this sort of you're looking to develop those relationships with those important stakeholders. I just wondered there about maybe investors. How do you see standards helping the company in the future? Will using national international standards make Delta G more attractive to investors?
I think we'll be less attractive if we don't. So yes, because we're not just sort of tooling around in the lab, and you have to have elements of agile development, rapid iteration at an early stage with complex, deep technology, such as Delta G. So we have to have the freedom to, rapidly iterate, learn, fail fast if we need to fail fast in certain areas. But as you go through product iteration, you need to be and locking into designs and getting ready for manufacturing. You really need to be locking in those, the quality protocols and the innovation protocols, and that's where standards can help. And then, in a positive way, ticking a box, but effectively ticking a box because you are complying and you've demonstrated a rigorous approach, is absolutely the kind of thing you need to do to prove to your investors that you're approaching things in an appropriate way.
Hey, Pete, you're currently working and supporting Delta G in its scale-up journey. I just wonder, your background, your experience, your professional background, and working with standards and using standards. How much have you brought that to that experience to your work with Delta G?
Well, Delta G is very, very promising research, and that's something I have not generated, but also I have generated through my career and experience in rapidly iterating complex hardware and sensor technologies, and the associated network around that. That's exactly what Delta G needed. So I'm actually by degree a master's degree in environmental scientist, so I quickly appreciated the value in the Delta G technology for obvious reasons, and I've worked in large corporates in utilities and infrastructure where standards are applied broadly, and I've also worked in smaller but complex systems engineering environments where standards are very much required, and 9001 is kind of always there, if you like, in terms of my experience. So, I absolutely, I'm definitely what Delta G needed at an early stage, but they're absolutely what I needed, because it's quite remarkable technology with very broad market applications, and it's about bringing complementary skill sets together that hopefully are setting Delta G off on a successful path. And there are various things we need to bring in as we scale, be it human resources, finance, government support, but then deploying appropriate systems and processes along the way that make this move from a very promising technology startup to an established global player that's supplying a range of industrial verticals with its technology.
I just wonder, Pete, where you are on the scale up journey and sort of looking to the future with this amazing technology, just how important will national and international standards be to that growth?
It'll be very important, because the end user customers that we're selling to are, large construction companies, large energy companies, large defense companies, and others. So they will not, they have certain restrictions such as ATEX or other standards they need to adhere to. And if we've not developed our devices and systems to meet those standards, they simply won't get over the threshold and be able to sort of be deployed into our target market. So it really is important that we approach things from the right way from the start. And even in our early iterations of the technology, think about those quality standards, think about innovation standards that we will be adhering to as we move along the journey. I mean, effectively, if we don't follow this, appropriate standard implementation, we won't be able to cross the threshold with our customers and supply our products to our customers, whether they be hardware, data, or both. So that's why we'll be looking. We'll be becoming approved suppliers of large global entities, and if we've not followed appropriate standard mechanisms, we won't be able to qualify to supply those customers.
So, Pete, quantum technology, a really interesting area of technology, and something that is sort of taking off now around the world. We actually have a joint technical committee, a standards committee at ISO and IEC level, looking at the issue of quantum technology. I just wonder, from your perspective, where do you see the growth for quantum and quantum-related technologies within the UK?
I think the UK has a great opportunity to create value for itself and globally by exploiting its significant capabilities and background in quantum technologies. And these broadly fit into quantum computing and quantum sensing. And I don't operate in quantum computing, but there's some really strong startups and scale-ups emerging that are seizing significant opportunities in quantum computing. But I operate more in sensing, and have engaged with various quantum sensing research these last few years that's kind of culminated in Delta G. And I think the UK has a really significant opportunity to provide the infrastructure to rapidly scale these technologies, because they can be realised, more rapidly in a kind of 3 to 5 year timeline, because you've got this great research that's approaching, mid TRL, lower to mid TRL, that now needs the appropriate, funding that the government's providing through the 2.5 billion that was announced last year for quantum technologies, has corporate pull, because corporates are more aware to these technologies and have the use cases which these things can be deployed to create value. And then the supply chain, which is already emerged around, from an R&D perspective, but there is lots of interest from the more broad components and contract manufacturing supply chain to pull through these quantum sensing technologies. So the UK really has an opportunity to pull through these technologies and create value for the UK, but then exploit these on the global stage.
My thanks to Peter Stirling for sharing his experiences about how his company, Delta G, is benefiting and plans to benefit from the use of standards to scale up. For more information about some of the issues raised in this episode, details of how to get involved in standards, and for details of other episodes in the series, then check out the links in the show notes.
You have been listening to the BSI Business Growth Toolkit, a series from The Standard Show, the podcast that brings you the stories behind the standards.
You just heard a stripped media production.